Welcome to Chapter 2, Section 2 for IM1 called Solving Equations. So we've already kind of solved some equations. I believe it was kind of the end of Chapter 1 where we were solving some of the equations. In this case, what we're going to do is we're going to be introducing what we called algebra tiles. So instead of having something that I drag around, I'm actually just going to draw them in this case, which is perfectly fine. They're just a visual that will help us see what we're adding and subtracting. So that is the purpose of an algebra tile. It's just a visual representation. So the main concept is the algebra tiles in this case. So use an algebra or an equation model to solve x plus 3 equals negative 4. So we have x, and they're using a green tile for x because it's just an unknown quantity, plus 3. So we have 1, 2, 3, and they have ones in them. We know that's 1, 2, 3, equals negative 4. And if you notice the negatives, a lot of the time they'll do this where the negatives are red, because red usually, means take away, negative, something along those lines. It's easier for us to relate in our head. I've actually seen the positive tiles also is green, and the algebra tile is blue. Kind of just depends on the set you're looking at. So when we want to take these away, what we want to do is what this does is it shows us there's 3 positives, there's 4 negatives, and there's 1 x. So we want to get this x all by itself, just like we normally would. So what they're going to show us to do over here is it says model the equation, place 1 tile, 1 x tile, 3 positive, 1 tiles on one side of the mat, place 4 negative, 1 tiles on the other side of the mat. So that's what I was just saying. Isolate the x term, add 3 negative, 1 tiles to each side. The resulting equation is x equals negative 7. The reason we're looking at 3 negatives is because I have 1, 2, 3. I want these to move to the other side. So I know I need 3, and I want to do the opposite. I want to get rid of those. And the way to do that is 1 positive to 1 negative, second positive to second negative, third positive to third negative, because 1 minus 1 is 0. So they all cancel out from each other on this side, and all we have left is x. And over here, we have to do the same thing. So I added 3 negatives. I have to add 3 negatives to this side as well. Or if you think about, subtracting 3 is another way to say that. So I already had 4 negatives. Now I have 3 more negatives. So since they're all negative, and this is hopefully a little easier to see visually, they're all the same negative. Just like if they were all the same positive, I'm going to add them together and say how many negatives do I have. So I have 4, 5, 6, 7. So that's why it's x equals negative 7. So we're always trying to get that x all by itself, or whatever the variable is in the case. All right, so let's look at this second activity. So it says use an equation model to show x minus 2 equals 1. So now we're going to place 1 x tile and 2 negative 1 tiles to show the negative 2 equals, and we're going to place 1 positive 1 tile on the other side. So we've placed all of these pieces. So we have our 3 pieces there, right? So now we're going to start moving these away from the x. We want the x all by itself. So in order to do that, I'm going to do the opposite. So 1 negative to 1 positive, second negative to second positive. So if I'm taking 2 away, I'm adding 2 to cancel them out. But remember, if I do it to one side of the equation, I have to do it to the other side. We have to keep it equal or balanced. So if I add 2 over here, I'm going to add 2 on the right. So I end up with x equals, and they actually just moved it over here for whatever reason, x equals 3. So in this case, they're actually showing you these are together, so they put them in a little group. And they have a little swoop over here, which just means they'd kind of go away. We'd cancel them out. So we would just have the x left over, and that would equal 3 ones, or just 3. So the idea of algebra tiles is just a visual representation of the problem. So let's go ahead and take a look at a few of these so that we can see. So let's see. I'll do the same colors they did. So we have x plus 4 equals 9. So here's my X tile. And then we'll do, oh, maybe we won't do it. Need to go, there we go. Now I can do yellow. Why is it letting me drop in there? It does. It just doesn't actually show up. I don't know if I like yellow, but we'll go ahead and use it just so that it kind of matches the problem there. So we have 1, 2, 3, 4. Oops. Why am I writing X's in those? Silly me. Those should be 1s because those are 1 tiles. And then we have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And those are all 1s as well. All right, so we have 9 1 tiles. And then in between there, we have an equal sign. So here's my left side of the mat and my right side of the mat. So again, this is just a visual representation. So it doesn't look like right now I have any negatives here, right? Everything looks to be positive. So what I need to do is I need to look at these tiles because I want to get this X by itself. So I need to move these 4 tiles to the other side of the equation. In order to do that, I need to do the opposite. I wanted only that to go away. So what I need to do is for each positive, I need a -1. So that way they cancel out on this side. So I can see I have -1, -1, -1, -1. So these are all going to cancel. Well, I have to do the same thing on this side. I have to do the same number. So since I have 4 over here, I have to have 4 over here on the right. So now these are going to cancel out. And then so are these. So just make sure you go 1 to 1. It doesn't necessarily have to be kind of right above it, but why not? So like that. And what we're going to do is we're going to write down what's left over. So X is left over equals, and then we have 1, 2, 3, 4, 5. So X equals 5. And if we think about that, 5 plus 4 gives us 9. So that does work. X has to be 5 in order for this to be true. All right, so let's go ahead and move to the next one. Oh, let me move this over so we can move. So we have X plus -3 equals -4. Oops. Why didn't it change here? Oh, because I have it down there. That's why. All right. There's my X. And then we have -4. Or sorry, -3. So here's 1, 2, 3. And then we have -4 on the other side. 1, 2, 3, 4. Like that. Unless I don't write the 1 very well. And I'm going to put my equal sign here, right in the middle. All right. So now, again, we want these away from this X. We want it all by itself. So in order to do that, I need to have my positives. Whoop. So for every negative, I need 1 positive to counteract it. So as I write 1 on that side, I'll write 1 over here. So here's another one. Same thing on the right. Here's another one on the left. Here's another one on the right. So I have 3 and I have 3. So what that's going to do is it's going to cancel out 1 negative to 1 positive. They cancel each other out. They become 0. So same thing on the left, or sorry, the right side as I did on the left side. And now I'm just going to write what's left over. So I have my X tile equals, and I only have 1 negative left over. So again, this is just kind of a visual to help us see what's going on in the problem. It's definitely a little easier for some students to visualize it this way. All right, so X plus 7 equals -2. So we have X. Sorry, my green ends up a different color each time I do this because I keep moving this pad around, but we're going to pretend like it's always the same green. And then we have +7. So we're going to go back to yellow here. We're going to have 1, 2, 3, 4, 5, 6, 7. And then we have -2 on this side. Okay, so we want these 7 away from that x. So for each one, I need 1 negative on this side. So that means I'm going to have 7 negative 1s, and I don't have a whole lot of room here. 2, 3, 4, 5, 6, there's 7. Like that. So these will match up. So I have to do the same thing on the right side here. I need 1, 2, 3, 4, 5, 6, 7. Sorry, that was a funny square on that last one. And so I'm going to go negative 1, negative 1, negative 1, negative 1, negative 1, negative 1, negative 1. Lots of negatives. Okay, so now let's go through and cross these out. So we have 1 positive to 1 negative, positive, negative, positive to negative. So each one should cancel out with another one. So there shouldn't be any of these left over. They should all cancel with 1. Over here, nothing is going to cancel because we started with negative 2 and we're putting 7 more negative. Remember, you can only cancel negative and positive. If it's the same, if they're positives on the same side, we would combine them. If they're negatives on the same side, we combine them. So we would have x left over on the left, and that's going to equal, and we just count how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, but we need to make sure we put negative. Because it's negative 9. Positive 9 would change the answer there. And again, if we think about that, I know I didn't go back on this one, but if we think about that, if we have 7 and we ended up with negative 2, well, that means we must have had a bigger negative number to begin with. So we had negative 9, which is 2 bigger than 7 if we think of just 9 and 7, and 9 is 2 bigger, so it's going to have 2 more negatives than the 7 positive. All right, let's go ahead and scooch over here. So let's see. Let's try to get a bright green again here. Nope, still kind of a pale green. So this says 5x. So this means I have 5 x's. Okay? So it means I have, and I'm not doing these the same size. Sorry, I should be doing them the same size, but they're not quite coming out the same size there. So we have 5 x's, and that equals negative 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now I need boxes. Almost there. Okay, so now we have 5 x's and we have equals negative 15. So when you have a situation like this, what we need to do is figure out how many of these negatives, we kind of have to divide up this side so that each one of these x's has the same number of negatives. So if we look at this, and I kind of set this up nicely. So we have 1, 2, 3, 4, 5 rows, and each row has 3. So I kind of set this up like this on purpose, the way I line this up, so that I could very easily separate them out into 5 equal groups. So however many x's you have, you want to quite literally divide up the other side so that it's equal. So now every x has negative 3 in it, or negative 1. 3 negative 1s. There we go. I can say that. So they would get the same number. So if I divide this by 5, I would end up with x, and I'll just write it down here, equals negative 3. So basically we're just dividing by 5, and that would be, there's 1 left, and when I divide by 5 on this side, that means that it would give me one of these groups. So it's kind of an interesting visual way to do it, but this is what happens with multiplication and division. We want, instead of just doing a positive and a negative tile that cancel out, we need to divide it up visually so I can see for every single x, I have negative 3. So I can kind of cancel out the rest and just say, okay, x equals one of those groups. All right, so let's take a look at this one here, because this one's a very similar type of problem. So this time we have And I'm going to actually do red this time because it's negative x, negative x, negative x. And so we have 9, negative 9 on the other side. Sorry. I know lots of drawing on this one. All right, so we have negative 9 on that side, and that equals each other. So they're both negative on both sides, and we'll deal with that in a minute because we don't really want a negative answer on both sides, but I'll explain how to deal with that in just a second. But what we want to do is that same idea, and again, I set this up kind of nicely because I was thinking about it visually in my head. Each negative x, we need to divide up this side so that they each get the same number. So again, we're actually going to have 3, 3, and 3. So each negative x has negative 3 in it. So negative x equals negative 3. And with this one, what we want to do is we want to fix this so that we don't have negative x, because you never want to type this into Alex like this. You always want a positive. And in fact, if it says x equals, it's already going to be positive. So whenever you have a variable that's negative, what you want to do is make that kind of go to the other side here. We want to make it positive. And basically, this is a negative 1. We just don't see it there. So what we're doing is we're just taking this negative 1 that's being multiplied by x, and we're sending it to the other side. You can think of it as division if you want, but really all it does is change this to positive x and positive 3, because since the negative is being taken from here and put on this side, now I have 2 negatives on this side, so it becomes positive. So it really just flips the sign around on us. So just keep in mind, you don't want a negative variable when you're typing in the answer there. Not necessarily that it's wrong. Negative x does equal negative 3, but it's not the proper way we would write that. All right, so now we have 4, x, 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 and I'll go yellow because that's what we were doing before. All right, 1, 2, 3, 4, 6, 7, 8. All right, I didn't necessarily do these the same way where they're visually already divided up for us. We are going to have to divide them up. So for each one of these groups, I need the same number of variables. I forgot the one, or not variables, sorry. Dang it. Oop, didn't change. 1, 1, 1, 1, 1, 1, 1, 1. Okay, now we can switch to that color. So I need to divide this up. So I can divide it up however I want to visually, seeing this, but I have 8 pieces and I have 4 over here. So if I cut it in half, that's 2 equal pieces. If I cut it in half again, that's 4 equal pieces. So each x is going to have 2 in it. So each one of these x's connects to one of these 2. Sorry, I'm trying to do that. So that means x equals positive 2, because each group has the same number in it. So again, just like I kind of did up here, I cancel these out, I cross them out, but you don't necessarily need to cross them out because you're saying each x belongs to a group of 2. So I know x equals 2 in this case. And again, we can kind of go back to this equation and think about it. 4 times something equals 8. Well, okay, that must be 2. 4 times 2 equals 8. That's the only number that will help get me that correct answer there. Alrighty, so that was section 2. I know that one took a little bit longer because of the kind of drawing issues here, but it's definitely a nice way to look at this if you've never seen Algebra Tiles. I think we do have Algebra Tiles in the center. If we really look around, we can find them, but it's definitely an easy thing to draw. And it's a nice visual way to understand the algebra. All right, so I will see you in section 3.